Today, we're taking a deep dive into one of the absolute biggest challenges facing data and analytics leaders right now. I mean, every enterprise out there is completely obsessed with automation, right? We're building custom APIs, deploying RPA bots, hooking up iPaaS integrations to speed up our workflows. But we're hitting a massive roadblock. We need to move from just kind of guessing the ROI of these automations, which, let's face it, is a massive headache for all of us, to definitively proving it. So today, we're going to build an advanced production-grade Looker model that isolates the exact fiscal impact of your automated workflows. Let's get right into it.
What is the actual dollar-for-dollar ROI of these automations? Yeah, that's the exact question from the CFO that keeps data engineers and BI architects up at night. And when finance leadership drops that question, what do most technical teams actually do? Well, they hand over abstract technical metrics. We've literally all been there. You proudly present this dashboard showing, your API runtime decreased by 40%, or maybe the system processed 10,000 more tickets this month. But to a finance leader, that doesn't prove profitability at all. It just proves your servers are busy. So the crucial point is this. We absolutely have to bridge this massive gap between those vanity metrics and concrete business value. I mean, telling an executive about API latency is wildly different from showing them a sleek dashboard that explicitly says, hey, we saved $412,500 year to date, and oh, by the way, here's an 84% efficiency gain. Today, we're distilling the source material to show you exactly how to engineer that exact transition, using some really advanced Looker techniques.
Here's our roadmap for this explainer. 1. The vanity metric problem. 2. The ROI architecture challenge. 3. Building persistent derived tables. 4. Dynamic ROI with Liquid. And 5. Designing the executive dashboard. Okay, let's dive into this with Section 1, the vanity metric problem, bridging the gap between technical output and finance expectations.
To bridge that gap and actually translate technical output into the universal language of finance, we really have to understand the core problem we're trying to solve here. The mathematical formula itself is actually pretty straightforward. You just take the legacy manual cost, subtract the new automated cost, and then divide the whole thing by your automation development cost. Sounds simple enough in theory, right? You're just comparing the old way to the new way. But as literally any data architect knows, executing this math in a messy, real-world enterprise environment, it's incredibly difficult. Which brings us to Section 2, the ROI architecture challenge. Why calculating real savings is incredibly difficult. You see, it all comes down to where and how the data is actually stored. Let's trace the data pipeline journey for a second. In most enterprises, the data landscape is just wildly fragmented. On one hand, you have your modern automation runs logged in these beautiful, clean, cloud-native API databases. Think AWS CloudWatch or Segment. But on the other hand, your legacy manual processes, the actual historical data proving how long a task used to take, are buried deep in outdated ticketing systems or legacy ERPs. And let's be honest with ourselves. Trying to match pristine AWS logs with a messy 5-year-old Jira ticket schema, that is the absolute bane of every data engineer's existence. It's incredibly painful. But in our architecture, these fragmented logs must somehow be brought together into a central warehouse like Google BigQuery and then accurately modeled via Looker. But wait, schema mismatch isn't even our only problem. To calculate cost, we obviously need to know the cost of human labor, and human labor costs fluctuate drastically. For example, if an offshore team handles a legacy process, the rate might be $25 an hour. But if a specialized onshore team takes it over, that jumps to $75 an hour. A customer support agent in 2024 doesn't cost the same as one in 2026. If we just hard-code these numbers directly into our database or our LookML, our analytics will instantly rot the very second a labor rate changes. Let's look at Section 3, building persistent derived tables, the engine behind our automation ROI model. So to solve this messy, fragmented data challenge, we're going to deploy our very first magical weapon in Looker, persistent derived tables, or PDTs for short. Let's break down exactly what our PDT is doing under the hood in the LookML. First up, it pre-aggregates millions of rows of raw API execution logs into nice, neat daily summaries by workflow. Second, it calculates the baseline manual legacy overhead. For instance, in our SQL Derived table, we can just tell Looker to assume each automated transaction historically took, say, 15 minutes of manual labor. Finally, and guys, this is absolutely crucial for performance, we use a data group trigger and an increment key on the execution date to rebuild this table nightly. Imagine a raw query scanning millions of logs taking 10 agonizing minutes to load on a CFO screen. No way. By rebuilding nightly, the PDT only processes new incoming data. So that 10-minute query suddenly takes 2 seconds.
This saves massive database compute costs in BigQuery while keeping our front-end ROI queries blazingly fast.
Moving on to Section 4, Dynamic ROI with Liquid, injecting flexible variables on the fly. Now, what's really interesting about this is that once we have our performance engine built with PDTs, we still have to solve that fluctuating labor cost problem we talked about earlier. We need our dashboard to be completely flexible. So how do we pull that off? We use Looker Liquid parameters. By defining a parameter in LookML, something like manual labor hourly rate, we actually give business users a text box directly on their dashboard. Through a liquid-infused measure, Looker dynamically injects whatever hourly rate the user types into that box straight into the SQL query before it's ever sent to the data warehouse. This means your finance team can just adjust labor costs on the fly, instantly recalculating the legacy manual cost without ever needing a developer to change a single line of LookML code. It is just incredibly powerful. And finally, Section 5, Designing the Executive Dashboard, the ultimate payoff for business leaders. All right, we've got the data pre-aggregated, we've got the dynamic inputs configured. Now we move to the Looker user interface for that ultimate payoff. When you're building an executive-facing automation dashboard, you really want to zero in on 3 core KPIs to prove that bottom line impact. You start with hours reclaimed. This is the physical time you've saved by comparing legacy manual minutes to automated minutes. But you know, operational time just isn't enough for the CFO, right? So you translate that into net fiscal savings, which is your true ROI. This is the literal dollar value saved after you subtract your automation infrastructure run costs. And to really drive the whole thing home, you scale this with run volume versus cost saved. Showing a stacked area chart proves that as transaction volume goes up, your savings scale exponentially, while your underlying automation infrastructure costs stay relatively flat. And this brilliantly illustrates the real magic trick of this whole setup. Just picture this. Your finance leader is looking at the dashboard. They set the manual labor rate filter to $35 an hour, and Looker shows Q3 savings of $120,000. Okay, great. But then they decide they want to see the ROI if it was a specialized onshore team doing the work. They toggle that filter to $65 an hour. Instantly, the dashboard recalculates, and those savings jump up to $240,000 in real time. You're not longer just presenting raw API performance metrics, you are presenting a direct, interactive contribution to the company's bottom line.
Thanks for joining me on this explainer. I really look forward to seeing how you apply this to your own Looker models, because by combining the high-performance aggregation of persistent derived tables with the dynamic front-end flexibility of liquid parameters, you have the exact tools you need to transform abstract system logs into concrete, undeniable business value. It's time to stop guessing your automation ROI and start actually proving it. So I'll leave you with this final question to consider for your own organization. Are you currently presenting server metrics or bottom-line value?